Hi, everybody. Rumor has it I'm the last talk for the day, so the only thing standing between you and beer is me. So if you want to have fun, clap a lot, make me feel good, and I'll get the hell out of here really quick. Yeah, there you go. So what I wanted to do is talk to you about streamlining your OpenStack deployment with web-scale networking. I don't know where you all are in your OpenStack journey, but we as a company, Cumulus Networks, we have been able and lucky enough to work with people all throughout the arc. We've got a bunch of customers that are in like early phase, kind of 2 racks, 3 racks, getting their heads wrapped around OpenStack. We were lucky enough to work with the DreamHost crew on OpenStack from the very, very early days, and they've got this pretty high-scale deployment themselves. We've worked with a couple of the other people that you've heard speak throughout today with the keynotes and other places at some very, very large-scale OpenStack deployments. And just to give you a sense of what we do, when you look at OpenStack, obviously you're using it to deploy virtual machines over a virtualized cloud infrastructure. Inevitably, you need hardware to make that shit work, right? You need servers that run OpenStack. You need networking equipment to connect your OpenStack instances together. So we provide a network operating system that runs on bare metal switches to provide kind of an underlay fabric for OpenStack. And then we provide visibility tools, Cumulus NetQ, that allow you to visualize networking throughout the whole stack, not only the switches and routers, but also what's going on your host and inside your virtual networking built into OpenStack. Lastly, we provide a piece of technology called HostPack that a lot of our customers use to build high-scale, full IP fabrics by using routing directly off of their hosts and connecting the host to an IP fabric instead of using kind of more brittle layer 2 technologies like MLAG. How many of you are early in your OpenStack deployment? Raise your hand. Actually, raise your hand first off if you're deploying OpenStack, period, or if you're just sitting here listening. We have 1 person deploying, 2, 3. Wow. Come on, 4, 5. All right, we'll give some people step up. So whenever you're early in that OpenStack deployment, it's usually really easy to just buy a switch or a couple switches or whatever, deploy a bunch of VLANs, start plugging your stuff together, and dig yourself into the myriad of pain associated with getting OpenStack up and running, getting your head really wrapped around this from a layer 2 perspective. You get the whole thing built up. It tends to work out pretty well. But at some point in time, you need a redundant, scalable fabric. You need to move this thing into operations. And what we see consistently is people move out of that layer 2 fabric into a layer 3 fabric. Across the journey, like the ultimate landing spot in that journey is when you run a routing protocol on your host, your hypervisor host. You connect into your IP fabric, all using something like BGP or OSPF. Gives you one protocol to evaluate all of your physical topology with. It gets rid of any kind of conundrums around MLAG or anything else like that with upgrading switches or hosts or anything else like that. And it allows you to use an overlay networking model for your virtual networking, which is by far more scalable than using VLANs to define your virtual networks. I'm going to walk you guys through a demo of kind of I'll call it a template layout demo of what we've seen customers do when they get to the very end. The topology I'm going to show you, it's really small. Obviously, I could have done this with a bridge, but it looks like 2 racks. We've got a rack over on the left, a rack over on the right. 2 servers are in each rack, dual connected to 2 leaf switches, so you have some level of redundancy there. And you have 2 spine switches, so everything's connected such that anything can fail. You can upgrade your switches, upgrade your hosts all along the way without taking out the rest of the system. I'm going to use a platform that we have. It's called Cumulus in the Cloud, and I'll tell you a little bit more about Cumulus in the Cloud at the end. But it allows you to, if you want to see how this all really works, you can go to our website, click on Try for Free, and it'll stand up a full OpenStack environment for you, along with like a little demo application, a couple of Zero servers stood up. So without further ado, I am going to kill the slideshow and switch over to the live demo. And this is where you, as all of you know, you end up taking your life into your own hands. So I don't know if you remember the topology I showed you, which I'm going to bring up again. Whoops, let me do this here. if you remember that topology, we had 2 servers in the left rack, 2 servers in the right rack. I chose server 01, the top one on the left, to be my control node for OpenStack. So if you go over to the Horizon dashboard, you see, well, you don't really see the controller itself, but you can see the other 3 servers showing up as hypervisors inside this environment. I've gone through, created a little demo application. I set up a network called DemoNet, and we'll dig into the characteristics of that in a minute. DemoNet gets routed to the provider network using a built-in OpenStack router. And then I deployed 2 virtual machines inside of DemoNet. One of them is native to the tenant network. The other one has a floating IP that gets out to the outside world. Going all the way back to DemoNet, if we get there quickly enough, what we're going to see is that it's built on VXLAN for its network virtualization. And just for fun, remember that the segmentation ID is number 17. So it's a VNI, if you're familiar with VXLAN, 17 that gets us there. So going back to our environment, let's take a look at it a little bit. Let's take a look at server 01. NetQ. We go through and look at server 01. Its origin route, its loopback address is 10.1.1.11. So that's what it's advertising out through BGP into the rest of the network. We can do the same thing for all of the servers, if I can get my cursor to do what I need it to do. We look at all of the servers and we see all of their loopback addresses. You'll notice the 10.1 network is what I use to advertise server origins out. They're all connected from their loopback through BGP with a multipath environment. So if I pop down to one of them just for fun to see what it looks like. I can see from server 01, I have equal cost multipathing to all the other servers in the environment. So again, like I said, any one of the switches in the system could be upgraded, taken out, go down, link fails, whatever you need from a redundancy perspective. And you have full redundancy in the fabric, but it's built on IP as well. So this thing will scales out really, really large. We have one particular customer that's got 2,000 switch nodes in their OpenStack deployment, all running using this technology. The great thing about it for them is from their ops team, the only thing they need to know to debug the network topology is IP routing and BGP, which is what all net admins know, and server admins kind of can get their heads wrapped around it pretty quickly. If you start looking at the cross-section where you're trying to get a server admin or a hypervisor admin understanding things like MLAG, it gets pretty psychotic for them because there's so much complexity in that brittle technology. So back to our little network. If we do netq show VXLAN, what we see is we see VNI 17. That was the segmentation ID we saw earlier. We can see all the nodes that lives on. So it lives, if you remember, actually, let's go all the way back here. When I look at my instances, obviously the control node is what was hosting my router to get out to the provider network. We can see that one of my servers, or one of my virtual machines is deployed on server 03. Another one of my virtual machines is deployed on server 04. Down over here, we can see that VXLAN environment get built up on server 03 and server 04. So what you can imagine is you see this virtual network scaling out. Obviously, one simple demo net, but if you're dealing with thousands of tenant networks, you're able to look at this sideways with NetQ type technology, understand what's going on under the covers of OpenStack in a way that you can't get from the OpenStack Horizon dashboards or any of this other standard OpenStack queries because it's kind of an aggregated view. If you want to go see how this works yourself, you can go to the Cumulus Networks website. There's a try it for free button in the upper right-hand corner. We give you the ability to choose a couple of different personality flavors to take a look at technology, whether it's a Mesos container environment, a blank slate environment, or what we were just looking at, which OpenStack, kind of click that button, wait a little while. You can get one of these personalized virtual data centers yourself, see how all the technology was deployed, see all the underlying automation necessary to roll the whole thing out, and then experiment with deploying virtual machines, building demo networks, building routers, and see how it all scales as you grow. Thank you.